So when we're clearing fractions, we want to look at the fractions and we want to look at the denominators. So we're going to start here with a denominator of 4 and a denominator of 3. So we need to think of a number that both of them can go into evenly. We want to think of the smallest number. So a quick, easy way, if you're not really sure about your multiples of what 4 can go into and 3 can go into, multiply them together. 4 times 3 gives you 12. So we're going to use 12 to clear our fraction. So what we're doing is saying 12 times 3/4 t, and we're doing 2/3 times 12. Okay, so think about these as fractions by putting them over 1. We can multiply straight across and then reduce, or we can cross-reduce first. So 4 can go into 4 one time, and it can go into 12 3 times, and then multiply straight across. 3 times 3 is 9t. And the same thing here. 3 can go into 3 one time. 3 can go into 12 4 times. Multiply straight across. 4 times 2 is 8. Then, to get t alone, we have to clear the coefficient. So 9t equals 8. So 9 times something equals 8. We'll divide by 9. Divide by 9. 9 divided by 9 is just 1. So we're left with just t equals 8/9. And that's our answer. All right, so let's go to number 2. So again, we can think about the smallest number that 3 and 5 can both go into. So if you're not sure, remember 3 times 5 is 15. You can use 15. So I'm going to multiply the whole thing by 15. So this is 15 times 2/3 and 15 times -3/5. Now instead of writing it all out like we did previously for each piece, I do a little quick cut that we talked about in class, if you were in class. So 3 into 15, so 3 goes into 15 5 times. 5 times 2 is 10. It's the same thing as saying 15 times 2/3, and we think about the cross-reducing. 3 gets reduced to 1, and 3 goes into 15 5 times, and 5 times 2 is 10. It's the same thing. But I say 3 goes into 15 5 times, and 5 times 2 is 10. Now we're going to do the same thing here. 5 goes into 15 3 times. 3 times 3 is 9, but I have that negative, so -9t. Then I divide by -9, -9, then t equals -10/9. And that would be my answer. Now remember, you should be checking these by plugging them back in to see if they actually work. So if I wanted to plug this back in, I know that the left side equals 2/3, -3/5, and my answer was -10/9, my solution. And negative times negative is a positive, and then I can cross-reduce or just multiply straight across. 3 times 10 is 30, and this is 45, and they should equal each other. Well, they don't look like they equal each other now. However, if I reduce them and I think about what can go into 30 and 45 to make it simpler, both of them are divisible by 15. So 30 divided by 15 is 2. 45 divided by 15 is 3. So 2/3 equals 2/3. So I know my solution is correct. All right, so we're going to skip down and we're going to do number 5. So the other 3 and 4 are very similar to 1 and 2. So let's do number 5. So with these, before we start solving, notice that we have a y over here and then a number, -3/5, over here. So this is that step when we did our notes for how do we solve equations last week. We want to make sure that we get all our numbers together. So we're isolating the variables on one side. Now we want to move our constants over. So we're going to add 3/5, add 3/5. Now when we do this, we're going to have to change these denominators, this half plus 3/5, to be the same. So that's a lot of extra work. So this is why clearing the fractions is so valuable. We want to get rid of those fractions so we don't have to deal with them. So we're going to look just at the fractions right now before we do anything, and we're going to go ahead and find something that would clear them. So 5 times 2 gives us 10, so we can use 10 to clear. So we have to do every piece, even the 2y, not just the fractions. Every piece, we're multiplying the whole thing times 10 because we got to have an equivalent equation. So 10 times 2y is 20y. A negative, we know it's going to be a negative. 5 goes into 10 2 times. 2 times 3 is 6. 2 goes into 10 5 times. 5 times 1 is 5. I forgot my y there. Now we have a very simple problem. Now we can easily move over our value. This is gone. We have 20y equals 11. Divide by our coefficient, and we get y equals 11/20. And we can plug back in to see if that works. So 2 times 11/20 minus 3/5 equals 1/2. And you can use your calculator to check to make sure that the left side equals the same as the right. If it doesn't, then you did something wrong. All right, so let's go up to number 6. It's a similar one. So here, we're going to go ahead and clear the fraction before we start moving things. So 5 times 3 is 15, so we'll use 15 to clear our fractions. So remember, we have to do every part. So y times 15 is 15y. There's a negative, so we know the negative is going to stay. 5 goes into 15 3 times. 3 times 2 is 6. So that means the same thing as negative 2/5 times 15 is the same as negative 6. Equals 3 goes into 15 5 times. 5 times a negative 1 is a negative 5. So now we have a very simple problem. Plus 6, we get 15y equals 1. Then we divide by our coefficient, so we get y equals 1/15. And again, plug it in. All right, let's go ahead and jump down to, we'll do number 8. So anytime we see fractions, we're looking at all the denominators, 4 and 2, and we're going to find something that they both can go into. Now with this one, I can multiply them and do 4 and 2 and get 8, but that's really not the smallest number. I know that both of them can actually go into 4, so I'm going to use 4. So remember, 4 is being multiplied by every piece. So 4 times 1/4. You can think about it this way. 4 goes into 4 one whole time. 1 times 1 is 1x. And then 4 times x is 4x. Then 4 times negative 3 is negative 12. Then 4 times a half. We know that 2 goes into 4 2 times. 2 times 1 is 2. X. So now we have simplified and got rid of all the fractions, and we're going to go ahead and combine like terms before we move. So notice we have 1x and a 4x here, so this side is actually simplified to 5x. The other side is already simplified, no more combining like terms. Then we're going to move our variables, so we're going to isolate the variables. So minus 2x minus 2x, we end up with 3x is equal to negative 12. Divide by the coefficient. So we get x equals negative 4. And then when you plug it back in, make sure it works. All right, we'll do one final one. We'll skip down to number 10. And the other ones you'll do on your own. So we're going to look at 3 and 4. Well, we know that 3 can't go into 4 evenly, so we can do the multiplying trick. So 3 times 4 is 12. So we're going to use 12 as our number to clear. And every piece gets multiplied by 12. So 12 times n is 12m. Plus 3 goes into 12 4 times. 4 times 2 is 8. 4 goes into 12 3 times. 3 times 1 is 3. M. And then 12 times negative 1. Each piece we've done. And we get negative 12. Now we can combine like terms on each side. They've already simplified. And now we're going to isolate the variable. So minus 3m minus 3m. So we end up with m's gone from the right. We have a negative 12 left. 12 minus 3 is going to give me 9 m's plus 8. Now we have the variables by themselves. We're going to move the constants, eliminate the constants to the side. So minus 8, they're going from this side. We have 9m equals, and a negative 12 with a negative 8 is negative 20. Divided by 9, our coefficient. 9 divided by 9 is 1, so we're left with just m, and negative 20/9. Okay, so when we plug that back in, we got to make sure if we plug negative 20/9 back in everywhere in the original problem where m was, it should be the same on both sides. Okay, so you can put that in your calculator and then double check.